Hello, it's Ms. Redmond again with another summary PowerPoint. This time it's about changes of state, melting and freezing. We're going to have a couple of lessons about changes of state because there's a few that we need to know about. The objectives for this lesson are to use the particle model to explain changes of state involving solids and liquids and to interpret data about melting points. Again, you'll want a pen or a pencil so that you can take notes and do any mini tasks that pop up. Changes of state are when a substance changes from one state to another. So in the last PowerPoint, we talked about solids, liquids and gases. And now we need to get the idea that you can change a substance from a solid to a liquid to a gas and vice versa, from a gas to a liquid to a solid. And those changes are called changes of state, which I'm sure you will have done. In primary school, you will have talked about changes of state, especially in the water cycle, and in your everyday lives, lots of times when you're cooking, you're dealing with changes of state. So, for example, this isn't really cooking, but if you have an ice cube in your drink, you know that it melts eventually. That's a change of state from solid to a liquid. Melting. Melting is a change of state from solid to a liquid. In melting, energy is transferred to the solid from the environment. So we're giving the solid more energy. And because we're giving the solid more energy, the particles in the solid get more energy and they start to vibrate more. Eventually, those particles can move past each other and they break out of their solid arrangement. So as more and more particles break out of their fixed solid arrangement, the solid melts into the liquid. And that's what's happening in the picture at the top. So we've got a lovely cold ice cream on a hot day, and energy from the air, from the environment. So the environment is the stuff that's surrounding whatever we're talking about. So in this case, the ice cream is what we're talking about, and the environment is the air around it and the hand of the girl who's holding onto the cone. So energy's been transferred for all of those things into the solid, and that's increasing the energy of the particles. They move around and eventually they can break out of their solid arrangement, and instead of a lovely cold ice cream, we get a runny, sticky mess. Freezing is the opposite change of state. So freezing is a change of state from liquid to solid. In this one, we're transferring energy from the liquid to the environment. So we've got an environment that's cold and we're transferring energy out of the liquid into the surroundings. The picture on this slide, is actually a frozen bubble. So this bubble started off as a liquid, and you can see that somebody's dropped this bubble onto some snow, so it's very, very cold, and we've got the energy from the liquid film of the bubble being transferred to the snow and being transferred to the air. So the liquid has less energy. So as the liquid particles have less energy, they start to move around less. As they move around less, they start to fix themselves into a pattern and simply vibrate vibrate in one spot, and the liquid freezes into a solid. So you can see that happening, not the particles, but you can see that happening if you click the link on this slide, because it's a video of bubbles freezing. It's really cool. Melting point. Melting point is the temperature at which a substance melts and freezes, which sounds really confusing. So the melting point of water is 0 degrees C. That means if you take ice, which is solid water, and put it in a room at 0 degrees C, it will start to melt. And it also means if you take water and put it in a room at 0 degrees C, it will start to freeze, right? Because if you take ice and put it in a room at 0, the ice is going to absorb energy from the environment, and that's going to make the particles move faster and the ice will melt. Whereas if you take water and put it in a room at 0 degrees C, the water will start to transfer energy to the environment and its particles will have less energy, so they'll start to move around less and eventually arrange themselves into a solid. So different substances have different melting points. That's another key point. Substances have different melting points. You've got a table here with 4 different substances and the table's showing you their melting point. So gallium is a metal and its melting point is 30 degrees C, which means if you put a lump of solid gallium on your hand, it will start to melt on your hand. Next substance you've got is gold, which you know is a metal. Its melting point is 1063 degrees C. So you have to heat that up a lot in order to make it melt. So both of those things, gallium and gold, are solids at room temperature. You know that because room temperature is 21 degrees C, about the temperature of the room you're in now. So if the room temperature is lower than the melting point, then that means that that substance must be a solid. You've got oxygen in there, which has a melting point of minus 218, which means at room temperature, from this data, we can't tell whether oxygen is a liquid or a gas at room temperature, but it's definitely not a solid because room temperature is much, much higher than the melting point of oxygen. And the last one we've got on there is water, which melts at 0 degrees C. So, again, we can't tell whether that's going to be a liquid or a gas from this data, but we know it's not a solid because room temperature is higher than its melting point. So it must melt before it reaches room temperature. Now, we know, because we're scientists, that oxygen is actually a gas at room temperature because it's in the air and we breathe it in and we need oxygen. And we also know that water is a liquid at room temperature that we can drink. Identifying substances. So as we've said, substances have different melting points, and because of that, scientists can use melting point to figure out what an unknown substance is. So this student in the picture is at university and she's got 3 different samples of painkillers, but she doesn't know what painkiller they are. So we can imagine that she's gone on the internet and looked up the melting point of those 3 different painkillers, or even better, looked it up in one of her textbooks, and she can measure the melting point of each of her painkillers that she's got and figure out which one's which by measuring their melting point. Okay, checking for purity. So a substance that is pure has a very sharp melting point, like on graph A. So you've got a graph there with time along the bottom on the x-axis and temperature up the side. And you can see that the graph is going up, but then in the middle of the graph it goes flat. Now what's happening there is that substance is melting. So we've got a solid in this example, we've got a solid and it's being heated up, so the temperature is being increased by heating, and in the first part of the graph the temperature is increasing because the particles of the solid are absorbing all of that energy and they're moving around more, so the temperature of the solid is increasing. But at the melting point, the solid is using that energy to change from a solid into a liquid, so the temperature isn't increasing anymore at that melting point during melting. And then after the melting point, the temperature starts increasing again as the liquid absorbs that energy. So that's what happens in a pure substance, the melting point is very sharp, so it's flat. In a mixture of substances or an impure substance, there isn't a sharp melting point because you've got different substances in there and they're melting at different temperatures. So we get a melting range instead of a nice sharp melting point. So we can use that to figure out if we've got any impurities in a sample. It's really, really useful if you're making drugs and you need to check that what you've made is a pure substance. All right, here's your summary slide. So these are the main points that you need to know. Melting is a change of state from solid to liquid. In melting, energy is transferred from the environment to the solid. So we're heating the solid up, basically. Freezing is a change of state from liquid to solid. In freezing, energy is transferred from the liquid to the environment. So we're cooling the liquid down. Melting point is the temperature at which a substance melts and freezes. Different substances have different melting points, and pure substances have a sharp melting point, so it's flat on the graph, and mixtures don't, so there's a melting range rather than a sharp melting point.